Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot. So go ahead and hit the subscribe button and let's get into the current video. I'm going to talk about the tabular integration version for integration by parts. And the idea is that if I have an integral that looks like this, so I've got an integral of a product, then integration by parts might be applicable. And if this p of x, this first factor, happens to be a polynomial, then not only is integration by parts possibly applicable, but also tabular integration might be the way to do it. Now, let me set up a specific example and run through the form or the technique for tabular integration. So let's say, for example, I've got the integral of x cubed plus 4x multiplied by the cosine of x. And I wanted to, again, compute this integral. Well, I know that this is applicable for integration by parts because I could, if I choose this like for my u, then remember my du would be a quadratic, which means that when I take the integral of u dv, it's going to be a quadratic times a trig function rather than a cubic times a trig function, which is a simpler integral. And then I could apply integration by parts again and again, ultimately 3 times. Rather than doing integration by parts 3 times, I'm going to set up the following table. And again, this is known as the technique tabular integration. I'm going to set up 3 columns. And my first column is going to be, let's say, p of x and its derivatives. The middle column is going to be sines. And the final column is going to be g of x and antiderivatives, where this is my p of x and this is my g of x. Okay, so I'm going to go ahead and set this table up here. What I'm going to do is I start by taking the polynomial term, so I'm going to record that at the top, so x cubed plus 4x. And I'm going to repeatedly differentiate this until I get to 0. That means I would get 3x squared plus 4, 6x, 6, and 0. Now for the middle column, I'm going to, starting with positive, I'm going to alternate the signs, 1 for each row until I get down to 0. So plus, minus, plus, minus, plus. For the third column, I'm going to start by listing the other factor, which is cosine of x. And then I'm going to repeatedly take antiderivatives until I get to this bottom row. Antiderivative of cosine would be positive sine. Antiderivative of positive sine would be negative cosine. And then so on and so forth until I get down to here. So antiderivative would be negative sine and then cosine. Okay. Now, after I have that set up, I'm going to draw the following arrows. I'm going to go from the first entry in this row to the second entry in this row and just draw a straight line. Okay, and I'm going to do that all the way down here until I get to, say, this the last non-zero entry. Okay. And now my work is done. And now I just have to interpret what this is telling me. Here are the results of the resultant terms for using this method. Each of these arrows represents a product, and I'm going to use the sign directly above the arrow. In other words, the antiderivative of this function right here is going to be x cubed plus 4x times sine of x. So x cubed plus 4x times sine of x. And then here I've got this quadratic, a negative with another negative, right? These are all multiplied together. Negative and negative is positive, so this would be positive 3x squared plus 4 times the cosine of x. Then the third term, I've got 6x, negative sine x with a plus in front, so the product of those three would be negative, meaning I would have negative 6x sine x. And then the last term would be negative 6 times cosine, so negative 6 cosine of x plus c. Okay. So this column was quick to do, this column was quick to do, this column was quick to do, and then you just interpret the results. So this is a whole lot faster than setting up an integration by parts table, say 3 times, and going through the formula and trying to sort through all of that, which is fairly straightforward for this example, but this is a whole lot more efficient. Thank you for watching. Please consider subscribing.